All right, AP Calculus self-check 3.2. Again, same date. It's October 23rd. Just for the record, 10/23/2020. Again, this was out of 6 for the number correct in the top right. Make sure you have that denominator. That means we were given 12 minutes. Let's do number 1. We have a graph of f prime, and we're trying to find intervals in which f is decreasing. So give me the definition of f decreasing, Andrea. Less than 0. Teflon, what is f prime on a graph of f prime? F prime is height. So translating this definition, where is height less than 0? And the answer is between 0 and 2 and 4 and 6. 0 and 2, 4, 6. The correct answer here is E. I can circle these two areas. All right, number 2. Oh, I should do fist of 5. Fist of 5 on number 1. How well can you do problems like number 1? A 5, and a 3. All right. Number 2. In the figure above, we have the graph of f prime. We're looking for points of inflection. So F, I, P. Fiona, definition, go. F double prime, sign change. Andrea, since this is a graph of f prime, what is f double prime on a graph of f prime? F double prime is slope. So translating this definition, where do I have a slope sign change? I have a sign change once. It's kind of hard there. Twice, thrice, and 4 times. The correct answer is E here, 4. Each of these has a slope of 0, and it does indeed switch to the other side. Fist of 5, how well do you know how to do problems like number 2 in the future? A 4, a 4, and a 4. All right, very nice. Number 3, we have a graph of the derivative f prime, and we're trying to find what could be the graph of f. The quickest way to do problems like number 3 is just look at how many times it turns. It turns once, twice. So I should be looking for something that turns 3 times. So that eliminates A, B, and C. If I'm taking the derivative again. So, or if I'm going backwards, sorry, if I'm taking the antiderivative. So that is between D and E. And why did I leave D? Because it tries to turn, but then it ends up not turning right here. If you remember, I mean, I briefly mentioned it, but I'll definitely label it right here. This is what's known in the biz as a saddle point. A saddle point. Why? Because maybe that's like the horse's head. I don't know. That's my horse. There's its eye. And there's the saddle that you would ride the horse. I don't know why it's named that. But yeah, it's a saddle point, which means it tried to switch signs in terms of being a maximum, being a relative extremum, but it ended up not happening. And look right here. On this graph right here, it was going to go from a positive to a negative height, which would have been the definition of a maximum. It was almost the definition of a maximum, but then it went the other way and ended up not being a maximum. It turned into a saddle point. So this right here is a saddle point. The correct answer here is D. Right over here on this graph of E, this would have meant that I have a maximum, a positive height to a negative height. Oh, sorry, that's not right. Let me think about this. So over here, I went from a negative height to a positive height, which means that is the definition of a minimum. And I do indeed have a minimum here and here. Right here, I would have had a maximum, but that isn't a maximum. So neither of those have a maximum, but this one does have a maximum at 0. So that's kind of the smoking gun. This is a minimum, which is okay. You can give the check. This is a maximum, which is not okay, because a maximum would have meant on the graph of f prime, I should have gone from a positive height to a negative height at x is equal to 0. And you can see at x equals 0, that does not happen. All right, fist of 5 on number 3. How well can you do problems like number 3 in the future? 3, 2, and 2. Give me a question or something that you messed up on. Tell me something.
So when you're trying to find the derivative, if there's 2 bends, you go down?
You have 1 less, yeah. And if you go backwards, then you should have more bends. So let me write this down as well. Taking derivative, that means 1 less, and I'll do that in all caps, less bend. And you know it's called taking integral because you've taken parts of this unit before. Going backwards, and I'll put in parentheses here, integral, means 1 more bend. And we are going backwards in this case because we were given the derivative and we have to go back to normal f, from f prime to f. All right, will that help for next time? All right, same thing, Teflon. Is it the bends that messed us up?
Don't know which, like, it's a derivative, and I don't know which way to go.
Which way to go in terms of bends or?
Like, if we're going backwards or keeping the derivative.
Okay, yeah, so, but you understood that the graph up above was f prime, and then the graph down below were f?
Oh, okay.
Yeah, I think just maybe slowing down and reading the problem might help us because it does say the graphs below are f and the graph above is the derivative of f. All right, let's do number 4. Okay, graph of f is shown above and we're looking for which of the following could be the graph of the derivative of f below. So all of these down here, I'll label them. That was a bad curly brace. All of these are f prime. This is a graph of f. That means I'm going forwards. That means if I'm taking the derivative, I should have one less bend. The tricky part about this problem is they don't draw the complete graph. You can see that down here, it bends and then it bends. It might keep going down. It might keep going up. We're not exactly sure. It looks like it's probably going to be bending back up. It looks like it's probably going to be bending back up. But the main thing is it had a potential of 3 bends, which means if I take the derivative, I should go down to 2. So I have a bend here, a bend here. That's a total of 2 bends. So it could be A. B is doing weird things. That's not even close. C is 2 bends. Again, bending once, twice. It could be C. D almost looks exactly like our original graph. It bends 1, 2, and 3 times. So it's not going to be D. That's probably going to bend down and bend down. And E doesn't bend at all. So it's definitely not E. So it's between A and C. And this is where I get to ask you about end behavior. My right hand is going up for my original graph up here. That means I have a positive function. Technically, it's a positive cubic. No, it's a positive quartic. Sorry about that. Ooh, cubic would have been 2 bends. This has 3 bends, so this is a positive quartic. You don't need to know the name, but it means it's a something degree 4, x to the power of 4. When I take the derivative, I should go down to something with the power of 3, x to the power of 3, x to the power of 3. Both of those are cubics. But notice that it's a positive cubic, which means my right hand should be going up. This one, this first graph of A, has the right hand going up. Correct answer is A. C has the right hand going down, which means this one was a negative cubic. And this A was a positive cubic. All right. Now that I've explained this, how well can you do problems like number 4 in the future? Fist of 5. 4, 3, and Teflon's at a 3. All right. Questions up to this point on any of these questions? All right, we're on number 5, and we're doing, I have to kind of rush through this. We get out at 9:17. I have a minute and 10 seconds. We have the property that f double prime, and f single prime, all of these things are negative, which means I should be going down for all values. Notice how A is going up right here, so it's not A. B is going down, C is going up, D is always going down, and E is always going down. Okay, let's take a look at f prime. That means that the slope should be going down. Oh, wait, f of x is height. This has positive height. So it's between B and D because it's going down and it's negative height. Going down and it's negative height. Now let's talk about f double prime. F double prime is concavity. This is concave down everywhere. The correct answer is B. Notice how D is concave up for the second half and concave down for the first half. So it's all about the concavities to decide between B and D. Fist of 5 really quickly before I do 30 seconds for the next one. 4, 4, and Teflon's at a 2. Okay, I'll maybe come back to you if I have time. This is a graph of f prime. I'm looking for relative maximum. Definition of f maximum, Andrea, quickly. F prime goes from a positive to a negative. On a graph of f prime, what is f prime? Teflon, quickly. F prime is height. So where does the height go from a positive to a negative? It's only at this one spot right here, and there's only one of them. Correct answer is A. And that concludes self-check 3.2. Give me the total out of 6 that you guys got at the very top right. Hold up fingers. How many did you get correct? 4, 1, and 4. All right.